Dear students, in the first video we derived time-dependent Schrodinger equation. Now we can derive the next equation, time-independent Schrodinger equation. We have the time-dependent equation as I cut dou psi by dou t is equal to minus h cut square by 2m dou square psi by dou x square plus b psi. This is the Schrodinger equation, time dependent equation. This is considered as equation number 6. Now we are going to derive the next time independent Schrodinger equation. Okay. So in number of cases, potential energy V of a system does not depend on time. It varies with the position of the particle only, and the field is said to be stationary. In such stationary problems, Schrodinger equation can be simplified by separating out time dependent and position dependent parts. So we can write the wave function as a product of a function of position and a function of time. Let us consider the function psi of t as a product of function of position and a function of time t. That is, psi of xt is equal to psi of x into psi of t. This is considered as equation number 7. I cut dou psi by dou t is equal to minus h cut square by 2m into dou square psi by dou x square plus v of psi. This is the time dependent equation, equation number 6. Here, instead of the psi, substitute this value, psi of x into psi of t. What do you get? I cut dou by dou t of psi of x into psi of t is equal to minus h cut square by 2m into dou square by dou x square into psi of x psi of t plus v into psi of x psi of t. Okay. Now, dividing the above equation throughout by dividing this equation throughout by dividing this equation throughout by psi of x into psi of t. Then what do you get? Then we will get I cut dou by dou t of psi of x psi of t divided by psi of x into psi of t is equal to minus h cut square by 2m into dou square psi of x into psi of t by dou x square divided by psi of x psi of t plus v psi of x into psi of t divided by psi of x psi of t. Now here we have psi of x into psi of t. Differentiation is with respect to time. So this term is a constant. Psi of x. Part of psi, it is considered as a function of x. Psi of x is constant here. So this psi of x and psi of x cancelled. Then what do you get? I h cut into 1 by psi of t into dou square psi of t divided by dou t. Dou t is equal to, here so differentiation is with respect to x. So this term is a constant. Psi of t is a constant. This psi of t and this psi of t cancel. Then you will get minus h cut square by 2m into 1 by psi of x into dou square psi by dou x square plus, here it is x only, v psi of x cancelled here. So here there is v only plus v. Okay. Now LHS is a function of t only and RHS is a function of x only. So the two sides LHS and RHS must be separately equated to a constant. This LHS can be equated to a constant and RHS can be equated to the same constant. So now consider this term RHS. Minus h cut square divided by 2m into 1 by psi of x into dou square psi by dou x square is equal to plus v is equal to a constant. That constant, it is taken as e. Okay. Then take this psi of x into right side. What do you get? Minus h cut square divided by 2m into dou square psi of x divided by dou x square plus v into psi of x is equal to e psi. Okay, e into psi of x. This is equation known as the Schrodinger time independent equation. In this equation, this is the time independent equation. Equation number 8. Okay, thank you.